Okay, this section is property of power series. We're going to learn to combine power series by addition or subtraction, learn how to multiply power series, and also differentiate and integrate a power series term by term. So we're going to have two power series, A and B, and we're going to take those two power series and we are going to do things with them. We're either going to multiply them together, or we are going to add them together or subtract them. We will not, we will not divide these at all. Okay, that we will not do. All right, so here is two power series A and B. First power series, A of X converges to some number A and B of X converges to some number B. Okay, so that is not supposed to be there. Oh, yes, it is. Okay, here we are. All right, so for addition and subtraction of power series, we are literally just going to take and add them term by term. Okay, so here's an example. So we have the sum, n equals 1 to infinity of n times x minus 3 to the n all over n factorial. That's A. And then I have the sum n equals 1 to infinity of minus 1/2 to the n. That's b of x. And then I am missing an x to the n. So then a plus b, a of x plus b of x would be the sum n equals 1 to infinity of, I can have n over n factorial plus minus 1/2 to the n times x minus 3 to the n. Okay, so that's an easy one. They both have the same terms. Another one might be the sum n equals 0 to infinity of x to the n over n factorial. And then I have the sum n equals 1 to infinity of x minus 2 to the n over 5 to the n. So that equals b of x. Okay, so if you notice, they both don't start at the same place. So I would have to peel off the first term of the first one. So the first term would be when n is 0, so a of x plus b of x. I'd have to take the a equals 0 term, that's 1, And then I can sum n equals 2 to infinity. I'm sorry, n equals 1 to infinity. And then I'm going to have x to the n over n factorial plus x minus 2 to the n over 5 to the n. And then the radius of convergence would be the smallest intersection of the two. Okay, it would be the smallest intersection of the two. So A converges on the absolute value of x less than 1, and B converges on the absolute value of x minus 2 less than 5. Okay, so this is minus 1 less than x less than 1. And this one is negative 5 less than x minus 2 less than 5. So this one will be negative 3 less than x less than 7. So therefore, if I combine them together, the total radius of convergence would be absolute value of x less than 1. Okay, so for the whole series, the smallest radius of convergence is the only one I can take. Okay. Any questions? That's just how you add power series, term by term. What's more difficult is multiplication of power series. That is not fun because it's term by term.
Being recorded.
Okay, so now we have two power series that look like that. All right, so most power series that we're going to look at are going to have the same term. So let me just do, they're going to be very similar to the one that I already did, which was that first one. Okay. All right, so let's look at, I don't want to do that. Okay, it thinks I want to add space. So let's add a little space, so leave me alone. Okay. All right, so if we take this out, write this out, this turns out to be A0 plus A1 plus A2 plus A3 plus dot, 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 dot times B0 plus B1 plus B2 plus B3 plus dot, dot, dot. Okay, so that is going to give me a power series that's going to have the sum n equals 0 to infinity of some Cn. All right, so what does the Cn look like? Well, that is the sum. Oh, I'm going to actually sum it. All right, so the first term, I can do A naught times B naught. So I get A naught times B naught. And then I can do A naught times B1 plus B naught times A1. And then I'm going to get A naught times A naught times B naught, B2 plus A1 times B1 plus A2 times B naught. And we'll keep adding them together. All right. And so you actually end up with this very long thing where you end up with each C1, each Cn is the sum k equal to 0 up to n of ak an minus k. Whoa. Okay, so let's try it. Let's get an example. because without an example, they are just characters in the wind. Sum n equals 0 to infinity of x to the n times the sum n equals 0 to infinity of minus 1 to the n x to the 2n over n factorial. Okay. All right, so the first term, all right, says take the first is going to be a naught, b zero, a0, b0. So the first term is going to be x to the 0. And then the first term of here is going to be negative 1 to the 0, x to the 0, x to the 0 over 0 factorial. So this is 1 times 1. That's 1. That's the first term of the series. So C1 is going to be A1 times B naught plus A naught times B1. Okay, so the second term, so basically this is what we have. We have 1 plus x squared plus dot, dot, dot. And that is multiplied by 1 plus 1 minus x squared plus x fourth over 2 factorial minus x to the 6 over 3 factorial plus dot, dot, dot. So that's what we have. These two series are multiplied together. So now my next is going to take 1 times negative x squared plus 1 times x, or x times 1. So I get negative x squared plus x. That's the second term. The third term, which is C2, is going to be A2 B0 plus A1 B1 plus A0 B2. So all you do is you start off with the first number at its highest and the B's at its lowest. The B's increase and the A's decrease. Okay. And so that's how you compute the multiplication of these two series. All right. So far, just for the first two terms, I know that this sum n equals 0 to infinity of x to the n times the sum n equals 0 to infinity of minus 1 to the n x to the 2n over n factorial. The first term is 1. The second term is negative x plus x squared plus x. And then you keep going. So that's a multiplication. All right, what's way more fun is differentiating these things. All right. So if you have a power series and it converges for some interval r, then you can compute its derivative by simply taking the derivatives of the terms. Now, one of the things we do not need to do is when you take, that should be n equals 2. Shucks, made a mistake there. Delete 2. When you take the derivative of x minus x naught to the n comes down and you get x minus x naught to the n minus 1. Then when you take the derivative of that, you already have n. The n minus 1 comes down and you get x minus x naught to the n minus 2. And so that is how you differentiate a power series. Okay, so here's an example. Okay, so we already know that we can find the power series for this. All right, so this we already know.
This meeting is being recorded.
Is equal to the sum n equals 0 to infinity of x to the n. Now we've shown that. And this converges on the interval that is equal to that series if the absolute value of x is less than 1. Okay, so if I take the derivative of this f prime, when I take the derivative of this, I get minus 1 over 1 minus x squared. Okay, and when I take the derivative of this, sum n equals 1 to infinity, I get n x to the n minus 1. Okay, so let's make sure that works. So basically that says then we already know that f of x equal to 1 over 1 minus x is 1 plus x squared plus x cubed plus x to the 4th plus dot, dot, dot. So that's the first one. And then this says to me that f prime of x equal to negative 1 over 1 minus x squared. If I differentiate the 1, I get 0. I differentiate the x, I get 1. Differentiate that, I get 2x. Do the derivative of the next one, I get 3x squared plus 4x cubed. So just by knowing one power series, I can find the derivative, its derivative, and end up getting a power series for another function. Okay. All right. I'm going to show you on Monday how to find the power series for e to the x. But in the meantime, I'm going to give it to you. All right. So the power series for e to the x, it is the sum n equals 0 to infinity of x to the n over n factorial. All right, so that's the power series for e to the x. It actually converges to e to the x, and it does that for all x. Okay, there is no specific place. All right, so what do I know about the derivative of e to the x? What function is it? The derivative of e to the x is?
E to the x.
Good, e to the x. So that means if I differentiate this other function, it should still be e to the x. So when I differentiate it, look at this thing doing this craziness. Oh, that's crazy. Go away. Go away. Oh my goodness. Well, at least we made it almost through the semester with no kinks. Now I have kinks. Technology for you. Everybody loves technology. I love a regular board with chalk. So if I differentiate this, I get the sum n equals 1 to infinity. Remember, anytime you differentiate, you start at the next level. So I'm going to get x to the n becomes nx to the n minus 1, and this is over n factorial. So this is the sum n equals 1 to infinity of x to the n minus 1 over n minus 1 factorial. Okay. And it's the same series. Okay, the last thing is integrating. You can integrate power series. All righty. So if you have a power series and you have the sum n equals 0 to infinity of c times x minus x naught to the n, and it converges under a radius r, then all you have to do is add 1 to the exponent and then divide by it. Okay, so you can add 1 and divide by it. All right. So here's one. I'll write this out. I showed you. So I am going to again post these notes so you can fill in any gaps that you may have in your notes. But here's my example. This is the power series for the secant of x. It does not have a nice formula. Okay, somebody actually calculated 1 x squared over 2 plus 5 over 24 x to the 4th plus 61 over 720 x to the 6th plus 277 over 8,064 x to the 8 plus dot, dot, dot. That is the power series for that. So therefore, what happens if I integrate that? What do I get? So if I take the integral on both sides, secant of x dx, and I get the integral of 1 plus 1/2 x squared plus 5 over 24 x to the 4th plus 61 over 720 x to the 6th plus dot, dot, dot. On the left-hand side, I get the log of the absolute value of the secant of x plus the tangent of x. And on the right-hand side, I get its power series. So 1 becomes x. Then I'm going to add 3, so I'm going to get 1 over 6x cubed. Then I'm going to add 1 to this, so I'm going to get 5 over 24. And then I'm going to get x to the 5th over 5. And then I'm going to get 61 over 720. And I'm going to get x to the 7th over 7 plus dot, dot, dot. plus an arbitrary constant. So just by integrating the secant, I can find the power series for its integral, which is that. Okay, it's been fun, guys. But the lecture for today is done.